This lesson is an introduction to the trigonometric ratios. You will also learn how to use the relationship between a sine and cosine of complementary angles. In this lesson, you will learn how to set up trig ratios, but we will not solve until later lessons. The trig ratios for finding a missing side, you will use sine, cosine, and tangent. To find a missing angle, you will use the inverse of sine, cosine, and tangent. A sentence that can help you remember your trig ratios is some old hippie caught another hippie tripping on algebra. So for this some old hippie, that sine is opposite over hypotenuse. Caught another hippie, cosine is adjacent over hypotenuse. Tripping on algebra, tangent is opposite over adjacent. So remember this sentence to help you know the trig ratios. Let's look at this example. It's completely done for you, so you can always refer back to it. First, notice our triangle. We have our theta angle, so that is our angle we're referring to. The triangle is labeled based on that theta angle. Of course, the hypotenuse is always opposite the 90-degree angle. Opposite the theta angle, you'll label the opposite side, and adjacent to the theta angle, you'll label the adjacent side, and then set up each ratio according to how the triangle is labeled. Let's practice an example on our own. This is the sine and cosine of complementary angles. So first, let's recall that complementary angles is the sum of angles that is 90 degrees. So two angles when they add together and equal 90 degrees. Well, notice in this triangle, we have y and x would have to add to 90 degrees because z is already a 90-degree angle. So the other two angles of this right triangle would add to be 90 degrees. So we're going to find the sine of y. In order to do that, let's first label our triangle. So y is our theta angle. We need to set up opposite and hypotenuse. So opposite is B, or side B. Hypotenuse is side C. So to find sine of y, it's going to be B over C. So let's go to the next triangle. We're going to do cosine of x. So label your theta angle, and then we'll label the sides of the triangle. The adjacent side is B, the hypotenuse is C. So cosine of x is B over C. Notice we get the same ratio. So sine of y is the same as or equal to cosine of x. And that is true anytime you have complementary angles. They add to equal 90 degrees. So let's look at example number 2. In the figure, cosine of A is 0.35. We need to find sine of B. So if you'll notice, A and B are complementary angles. Therefore, sine of B is 0.35. Let's look at example number 3. We're going to write the sine, cosine, and tangent ratios and their inverses of each for the theta angle. So from our theta angle, let's go ahead and label our triangle. It's probably easiest to label the hypotenuse first. We always know that's opposite the 90-degree angle. After labeling your hypotenuse, I find it easiest to label the opposite side. So opposite of the theta angle, and then the adjacent. Of course, it does not matter the order you label those sides. As long as you label opposite, adjacent, and hypotenuse, they do need to be labeled correctly to set up your trig ratios. So for sine, the ratio is opposite over hypotenuse, some old hippie. So sine of theta is going to be B over A, the opposite side over the hypotenuse. So to do inverse, angle theta is going to equal the inverse sine of that same ratio, b over a. Let's set up cosine. Cosine is adjacent over hypotenuse, caught another hippie, so cosine adjacent over hypotenuse, so that'll be c over a. Of course, the inverse, so theta is equal to inverse cosine of c over a, that same ratio. And finally, for the tangent ratio, tangent is opposite over adjacent, so tripping on algebra. So T for tangent, opposite is our side B, and adjacent is our side C. And of course, for inverse tangent, it's the same ratio. Angle theta equals inverse tangent of the B over C. Let's look at example number 4. We're going to again write the sine, cosine, and tangent ratios and its inverses for each for the given angle. So this time our angle is actually a measurement of 53.13. It's approximation. It's not exactly that value. So first, for our triangle, let's label from that theta angle. Of course, the hypotenuse is opposite the 90-degree angle. Opposite our theta angle, we have the 4, and then adjacent is the 3. So for our sine ratio, we need sine of our theta angle, so the 53.13 equals opposite over hypotenuse, so the 4 over 5. We're just learning how to set these up at this time. To do inverse sine, it's angle theta, so our 53.13 equals inverse sine of our opposite over hypotenuse, so 4 over 5. We'll do this again for cosine. Cosine is the adjacent over the hypotenuse. So we'll do cosine of our angle, so cosine of 53.13 equals the adjacent side is 3 over the hypotenuse, which is 5. To set up the inverse, we do our angle theta, so 53.13 equals inverse cosine of that same ratio, 3 over 5. That's our adjacent and hypotenuse. And finally, now for tangent, opposite over adjacent. So tangent of theta, so tangent of 53.13 equals the opposite side is 4 over the adjacent side, which is 3. Set up the inverse for tangent also. So 53.13 equals inverse tangent of 4 over 3. Just learning right now how to set these up, and I'll show you here in a moment how to check them with your calculator. Let's go ahead and look at example number 5. We're going to write the sine, cosine, and tangent ratios and their inverses for each of the given angles. So again, let's start with our triangle, labeling our theta angle, and label your sides. Our hypotenuse is opposite the 90-degree, and then do opposite and adjacent from that angle. Opposite of the angle and adjacent to the angle. For sine, we would need opposite over hypotenuse, some old hippie. So sine of 30, sine of our theta angle, equals the opposite side is 4, and the hypotenuse is 8. For our inverse, we do our angle theta equals inverse sine of that same ratio, 4 over 8. Let's do cosine now. Cosine caught another hippie, so we need adjacent and hypotenuse. So cosine of 30, the adjacent side is 4, the square root of 3, over our hypotenuse, which is 8. And of course, do the inverse. So we have 30 equals inverse cosine of that same ratio, 4, the square root of 3 over 8. And finally, now for tangent, tripping on algebra. So tangent is opposite over adjacent. We have tangent of 30 equals 4, which is our opposite side, over adjacent side, which is 4 the square root of 3. And then do the inverse of that. So 30 equals inverse tangent of that same ratio. Again, notice we've just set up the ratios. We've not been solving anything. We're just learning how to set up each ratio. But we can check these in the calculator. So let's look at that. The calculator can use to check your ratios, but the calculator must be set in the correct mode. So you'll press the mode button. The mode button is here beside the second button. So when you click that, you get this screen. You will arrow down to the line that says radian degree. So you'll have to arrow down till you're on radian degree. You will arrow over to highlight degree and press enter. You must select that word where it says degree. We need to be in degrees mode because the triangles we are working with, the angles are measured in degrees. 30 degrees, 27 degrees. You can exit this menu by pressing second and mode. Notice the quit is in blue, so second quit to get out of that screen. But you must be in degree while working with these ratios, sine, cosine, and tangent. So if we go back to number 4 and type in some of our answers. Sine of 53.13, we see that decimal. We said that equal the ratio 4 over 5. So we see this decimal. And if you rounded, those would be equivalent. 53.13, if you'll remember, was an approximation for the theta angle. That's why they're not coming out exact. Again, we can check the cosine ratio. We said cosine of 53.13 equaled the ratio 3 over 5. And again, with some rounding, those would be equal. We can also check the inverse ratios. So if you do inverse sine, you'll need to do second and then the sine key. That's how we find the things in blue is second and then the button. So inverse sine of our ratio, here is our angle 53.13. We see that for each of our inverse ratios, when we type those in, we can check them that they equal that theta angle. We can do the same for number 5, checking each of our solutions. For sine, cosine, and tangent, we can check the ratios with our work. We can also check the inverse. So inverse sine, cosine, and tangent, typing each of those in, notice it does give us that theta angle as our work is set up. Sometimes we must use an online calculator. So let's talk about the Google calculator. As we just observed, sine of 30 is 0.5 or 1/2. So that's a good one to check to make sure your calculator is in the right mode. If you just Google calculator, this comes up. Here is the options to change from radians to degrees. But if you just check sine of 30, you should know that that's 0.5 to make sure you're in the right mode. You could also do inverse. You'll press the INV here just below the mode. Press that INV to activate the inverse trig ratios. So again, you can check with inverse sine of 1/2, you should get 30 to make sure it's in the right mode. So let's move on to our next example, number 6. We're now going to determine which trig ratio we would be able to use. So we're going to write the appropriate trig ratios and its inverse for the given angle. So we have our theta angle, which is 32 degrees. Hypotenuse is opposite the 90-degree angle. The 5 is the opposite side because it's opposite the theta. and the 8 would be adjacent. However, we don't need that hypotenuse. It's not labeled, and we're not asked to find it. So I don't recommend labeling things that you don't have any information about or you don't need any information about. Only label the information that you know or need to know. So from this information, we can look at our ratios for sine, cosine, and tangent. Notice we have the opposite and the adjacent, so that would be tangent. So we can set up the tangent and inverse tangent ratios from this information. So tangent of 32 equals opposite over adjacent, so we'd put the 5 over the 8. We can also do the inverse tangent, so our angle, so 32 degrees, equals inverse tangent of 5 over 8. Both of these we could check in the calculator. Let's look at number 7. Again, let's label our theta angle. Our 6 is the hypotenuse opposite the 90-degree angle. We do not know the opposite side or need to know the opposite side, so we will not label that. But that 3 is the adjacent side. So from this information, adjacent and hypotenuse is cosine. So we will set up the cosine ratio and its inverse for this triangle. So cosine of 60 equals adjacent over hypotenuse. So 3 over 6. We can also do inverse cosine. So angle theta, so our 60 degrees, equals inverse cosine of 3 over 6. And once again, you could check both of these in the calculator. Let's look at example number 8. Again, label your triangle. We have our theta angle, our hypotenuse, and the opposite side. We will not worry about labeling the adjacent side because we don't know it and we don't need to know it. So let's not include that label. It would confuse and make it hard to decide what ratio we would need. Opposite and hypotenuse, notice that is sine. So our sine ratio, we'll do sine of 56 equals the opposite, which is 5, over the hypotenuse, which is 6. And of course, for the inverse, we'll do our angle theta, so 56 equals inverse sine of the 5 over 6. Again, be sure to check those in the calculator. So you will use the trig ratios in later lessons to solve. Today, it's just important that you learn how to set up and learn these trig ratios.